I'm Nathan Buchholz, a freshman TAM engineer.
I'm Tyler Green, and I'm a sophomore in mechanical engineering.
Hi, I'm Samantha, and I'm a freshman in civil engineering.
I'm Eric Quintanilla, and I'm a senior in mechanical engineering.
Our team name is Headspace, and together we created an addition to a middle school sink to allow disabled students to turn the sink on and off independently.
Our client was Kelsey Wells. She's a special education teacher at a middle school, and her students have a range of physical disabilities. They are the true clients of her project, and their physical disabilities limits the strength to grip and push or pull objects. It also limits their coordination and their reaction time. So these were really the constraints that we had with our design. We had to take that into account because we couldn't have a system that would overexert the students and their strength, or maybe go above their coordination, or that would take them forever to try to work with. And the problem was that the faucet valves were hard to open and close, and so they would have problems trying to do it on their own. Also, the sink was too high, so they would struggle to try to get to the levers themselves. They could wash their hands, but they needed help trying to turn it on or off. And they also wanted to feel more independent. As children, especially in middle school, they wanted to be more like all the other students. So they felt that independence was a big part of what they wanted to do, but not being able to turn on the sink by themselves was hindering their growth. And the goal was to design and create a modification to the existing sink that allowed these students to turn the sink on and off so that they could feel more independent.
The first thing we wanted to do was to go to the middle school and meet the clients firsthand. By meeting the students, we were able to figure out which motions they felt more comfortable with. For our design, we wanted to try to incorporate some of these so that they already had a step up on what we were building, and they weren't trying to learn something completely new just to make it that much easier for them. From our visit, we were able to come up with the most important values, the top of those being safety, durability, and ease of use. Safety for obvious reasons. With durability, we didn't want to give them this freedom only for it to be taken away in a month when our design falls apart. So that was really important to us. And lastly, ease of use. So for the students, we didn't want to, them to need any extra assistance. That was the whole point of this project, to give them the independence to be able to do it by themselves. With these in mind, we decided to go for a purely mechanical system. We felt it would accomplish our goal and keep our values at the top of the list and follow right along that path. So right away we got to prototyping. In order for us to better evaluate our ideas, we wanted to have a physical representation so that we could see some ideas see some issues that we might not have otherwise thought about. We knew from the beginning that coming up with a lot of iterations was going to be key for this project. We couldn't ride with something that was not going to accomplish our main goal. So after we had this prototype, we moved into a CAD assembly to see a better idea of what it might look like if we use it for the final project. And after we did that, we went and consulted with some ITLL engineers to get their expertise on how they thought the design would function if it was manufactured, and also how they might manufacture it, things like what they would make it out of or how they would make specific parts became really important to us.
Here's a CAD model showing how our design would function when installed. So on top we have a handle that would be connected to the cold water lever on a sink. So someone trying to use the sink would press on that left lever. That's going to cause our handle to rotate and turn on the sink. That handle is also going to cause our bottom right lever to come forward. So now when someone wants to turn the sink off, they're going to press on that bottom right lever. This lever has a system of gears in it in order to reverse the motion of your push. So pushing on that lever is going to cause the sink handle to rotate the other way and turn off.
The next steps for our project are centered around the hope that another team can pick up where we left off and manufacture a working product for our client. Adding a gearbox to the design to protect the gear system will maintain the durability and safety of the product so that nothing can interrupt the system and no one could be harmed by its movement. Adding color to the paddles could also be beneficial, as Miss Wales students practice using their pushing and pulling skills with brightly colored toys, so the appeal of the product and their recognition of how to use it is important. We believe our product can assist young students in gaining a sense of independence while using the restroom at school, but it shouldn't stop there. The same students that struggle to operate the sink at school are also having difficulties at home. Manufacturing this product and making it available to the public with the capability of attaching to many styles of sinks could change the lives of these students at home as they continue to feel a sense of independence and their ability to turn the sink on and off on their own. Our team has grown a lot through this process. We learned how to work together, even once the course was moved online, to complete a fully functional CAD model and detailed outline for the project we designed at the beginning of the semester. We have taught each other new skills and carried the team in areas we may have already been familiar with. Overall, we moved forward in our engineering journey with more knowledge than when we first met.